For number 2, we are given the graph of f prime and need a graph f. We're also given that the graph is falling and then rising, and that there's a sharp turn at the origin. From the graph of f prime, we can see that f prime is always decreasing, meaning that f will always be concave down. We can also see that to the left of 0, f prime is under the x-axis, meaning that f prime is negative to the left of 0. So f will be decreasing to the left of 0. We can also see that f prime is above the x-axis to the right of 0, which means that to the right of 0, f prime will be increasing. So the graph should look something like this.
So problem 2 also asks us to graph the function of f double prime with f prime given to us. First, before we draw the graph, we need to identify the characteristics of the graph. The easiest thing to see is if the graph has any point where the slope is 0. But as we can see, it doesn't seem like there are any horizontal tangent lines at f of the function f prime. So that means there aren't any x-intercepts of f double prime. There aren't any points of inflection either, so we need to move on to other characteristics. As we can see, it seems like the graph of f prime has a vertical asymptote at x equals 0. That means f double prime also has a vertical asymptote at x equals 0, since we are graphing the slope of f prime, which is undefined at x equals 0. The slope also seems to increase in magnitude as it gets steeper and steeper as it approaches 0. So the output value of the function f double prime also increases greatly as f double prime approaches 0. So it gets steeper and steeper. The slope seems to also be negative for all from negative infinity to 0, negative, and 0 to infinity, negative. So that means that the graph of f double prime is drawn in the third and fourth quadrants because we are graphing the slope of f prime, which is negative. So now we should be able to draw the graph. So we know that as it's increasing, that that f double prime has a vertical asymptote, and as it's approaching 0, its magnitude is increasing. So it should look something like this as it's approaching 0. Something like this. And for the other part, we know that as it's approaching infinity and negative infinity, it seems like as if the slope is trying to approach 0 or trying to have a horizontal tangent line. So that also means that there's a horizontal asymptote at y equals 0. So it should look something like this. So f double prime tells us that the graph of f, since it's a second derivative, will always concave down since it is negative.